And now, without any further delay, let's begin today's event. Once again, Artificial Intelligence in Financial Crimes, sponsored by FAST and hosted by American Banker. I would like to introduce your moderator for today, and that is Mike Sisk. Mike, you now have the floor.
Thanks very much, Christina, and I would like to welcome the audience once again. We are very grateful that you have chosen to share some of your busy day with us. We know that your time is valuable, and we will honor that today with what I'm confident is going to be an enlightening 60 minutes or so of discussion. Once again, our topic today is artificial intelligence in financial crimes. And my name is Michael Sisk. I will be your moderator today. I've been a New York-based journalist for about 20 years, and I've had stints as editor-at-large at U.S. Banker and contributing editor at Bank Technology News. And besides American Banker, of course, my articles have appeared in Barron's, Crane's New York Business, Inc., Institutional Investor, Strategy and Business, and Worth. And I am very, very pleased to introduce our three excellent speakers today. The first is Kerem Muezzinoglu. And Kerem is a principal staff scientist on the SAS Fraud Management Advanced Analytics team. His expertise is building predictive analytics solutions for financial fraud. He holds a PhD in electrical and computer engineering and also worked as a research scientist at UC San Diego on machine learning theory and applications. And we're very pleased to have Kerem along with us, as well as Carl Suplee. Carl is Director of Product Management for Fraud and Security Intelligence at SAS. He is responsible for product direction, strategic development, and domain expertise for the financial crime solution portfolio. In addition to working closely within the financial crimes industry, he partners with SAS research and development and implementation teams to deliver industry-leading solutions for financial crimes. We're also very happy to have Carl with us today. And rounding out the panel is David Stewart. David is Business Director, Security Intelligence Solutions Banking at SAS. David leads strategy development, drives product management, and provides key marketing counsel for fraud and compliance solutions worldwide. In addition to working closely with many of the world's leading financial institutions and regulatory agencies, David collaborates with SAS research and development and delivery teams to deploy industry best practices for financial crimes solutions. David leads a team of global subject matter experts with industry expertise in preventing fraud and managing financial crimes risk. And we are also very, very happy to have David with us today. And just before we jump into the real kind of meat of the discussion here, I wanted to reiterate two things that Christina mentioned at the top, and that is that we do have time at the end for Q&A. Usually we set aside around 10 minutes or so. And you don't have to wait until the end to put your question into the queue. You can do that throughout the hour as the question occurs to you, and we encourage you to do so. We'll make every effort to get your question in the time we have today. If we run out of time, which sometimes happens when we've got lots of great content, sometimes it's just a question that's better addressed kind of one-on-one. Whatever the reason, we will definitely follow up with you afterwards. So if we don't get to it today, we definitely will. We will reach out to you, so please ask away. We really do want to hear from you. And we also have a couple polls. And I always encourage 100% participation. We do share the results with everyone here, and it's a really nice way for everyone that's participating in the program today to see where other folks stand on the question that we've come together and the issue we've come together to discuss. So that would be wonderful if you could weigh in on that. And I think that brings me to the end of my little opening spiel here. Let me officially turn things over to David to really get us underway here. David, please, the floor is yours.
Well, thank you so much, Mike. Today, the objective of our session is to, one, provide a common understanding of what we mean when we use the term AI. We have a lot of tangible examples that we'll present today that will demonstrate how we're seeing financial institutions adopt AI to manage fraud and compliance risk. And we'll take advantage of our industry practitioners, Kerem and Carl, and they'll help you understand where and how you can potentially embed AI into your existing processes. If we look at the topics, first I'll spend a few minutes kind of getting us on a level set of a definition of AI. We'll talk about the detection and investigation life cycle and various approaches for pragmatic adoption. And then we'll spend most of the time going through use cases, which I've kind of split into subject areas of automation examples and detection examples, and we'll wrap up with takeaways, kind of pragmatic recommendations for how you might get started if you're early on in that journey. So first, let's make sure we're on common ground in terms of what the definition is of AI. In SaaS, there are many different definitions in the industry. Our definition is AI is the science of training computers to perform tasks that typically require human intelligence to complete. So what's the reality of the current state of AI? At its core, it's the ability for the machine to apply logic and reason to gain understanding from very complex data. So simply put, the machine can learn from the data it's provided by identifying patterns and relationships that exist within the data itself. The machine's able to, one, ingest massive amounts of information, two, extract key features, determine a method of analysis, write the code to execute that analysis, and three, produce intelligent output through some sort of automated process with minimal intervention, but nonetheless substantial influence from its human counterparts. So it's also helpful to look at the evolution of advanced analytics over time. If we look back at the evolution of AI and subgenres of advanced analytics, it really started in the 50s. In 1952, Arthur Samuel wrote the first computer learning program designed to play checkers. In 1957, Rosenblatt wrote the first neural network designed to simulate human thought patterns. In 1979, SAS actually introduced its first machine learning algorithm for discriminant analysis. And into the 80s, vendors like SAS and others wrote algorithms to perform logistical regression, pattern recognition. And into the 90s, these expanded beyond what you would think of as classical statistical procedures to things like decision trees, neural nets, and ensemble models. Now, I think the reason that AI has come so much into our purview is in the last decade, we've seen Watson in the evening win at Jeopardy. And in 2016, Google's AlphaGo beat a world Go champion 5 out of 5 times. And if you're familiar with the Asian game Go, it's a game that was previously thought too complex for computers to solve. Which takes us to the present, where we have in our homes things like Siri and Alexa, and we communicate with chatbots online. And we use our smartphones for facial recognition to authenticate payments. What I think is different when we look at this graphic and you think of AI in the context of the 1950s to where we are today is just the barrier to entry for a financial institution has become attainable. That is, today's commoditized systems allow data scientists to crunch much bigger data sets much faster, and we can run hundreds or thousands of iterations of these analytical techniques so that our models achieve better results, much better results than really what's been previously possible. So Mike, do you want to take us to the first polling question?
I do. Thank you so much. So as promised, we have got the first of 3 polling questions here. And what I'm going to do is read through the question and read through the answers. And hopefully in that time, everyone will have had an opportunity to make their selection. So where are you in the adoption of AI in your fraud, financial crimes, risk mitigation? Are you currently using AI in production? Are you currently engaged in an AI pilot project? Are you planning to pilot within 3 to 6 months? Or do you not have plans at the present? And what we're going to do here now is I'm going to turn things back over to David. He's going to go through another slide, and then that'll give you a little extra time to make your selection, and then we will share the results with you in just momentarily after that. So thanks everyone in advance for participating in this, and let me turn things back over to David.
Thanks, Mike. So one of the objectives for today's session is to prompt your thinking about how and where you can deploy AI to provide tangible impact. In this visual, I'll think of it simply as the detection investigation life cycle, but obviously it's more than that. It really depicts the various business processes from data to alerting to how we manage alerts or investigations or resolve those work items to how we optimize the entire process in a more iterative, ongoing fashion. So we'll cite some examples today that touch a number of these processes. And we're not suggesting that you take a sequential approach per se around the wheel, but we do see most clients identifying low-hanging fruit in terms of automating manual processes, or they seem to be deploying advanced analytics for specific behavioral use cases that have been traditionally difficult to detect with rules-based systems. So Carl, we were just traveling together in Asia, and we were asked that question, like, if you're about to take on a more advanced analytic approach, where do you start? What's most important?
Yeah, so thanks, David. So I think the key thing here is really understanding your business problem. It's really understanding what are you trying to accomplish with leveraging AI or really leveraging any kind of a model-esque format in your program. And I think it really starts off at the beginning just with data, really understanding the data. What data is available in your particular firm, and the quality of that information. So to me, that you've got the data prep and the data exploration. To me, those go very much hand in hand. So it's not only getting access to data and understanding where the data comes from, but it's also understanding where what's the makeup of that data? How is it formatted? Even if you've got data coming from multiple different sources and you're trying to bring it together, how is it connected? And this is the hardest part of this whole equation, right? In my mind, artificial intelligence is only as good as the data that goes into it. And if you don't take the time to really understand your data, understand what you have and how you can use it, and how good it is, then there's not a lot of point, in my opinion, spending a lot of time trying to integrate artificial intelligence into your program. So this is, to me, it's a crawl, walk, run phase, right? So you want to go in and evaluate the data, look at it, understand what you can use. You might start small with just some basic data elements, do some feature engineering of that data, and then start to add on to it as you get a better understanding of the data, and also maybe going through some cleansing exercises in your organization. So those are definitely some things I would take into consideration.
Thanks, Carl. Kerem, Carl used a term that we hear a lot these days, especially when we're trying to determine response times, when we're thinking about real-time decisioning. But describe for the audience what we mean when we use the term feature engineering.
Yes, thanks, Dave. So this is actually all the historical data that there is a long list of questions that we typically ask on the historical data for its qualification for a fruitful modeling exercise. And pretty much all of them kind of boils down to the main question that how representative is this data of the problem? And one of the very important aspects that actually determines the fate of this modeling is actually, do you have representative bad examples, be it fraud or some kind of criminal behavior represented well in the data? And that actually is a very desirable attribute, that if the bad examples are representative and it can draw a complete picture of the bad behavior that are being targeted by this model, actually we typically follow a supervised approach and actually design our features, design the predictors out of that raw data with very clear examples to show to the training process. But not all channels are that lucky, and in many cases, be it because of operational immaturity or just being not in the scope, the detection problem at hand might actually not be very clearly understood from the data, in which case we have to resort to certain unsupervised techniques which are anomaly detection, or just find what is normal from the data and try to detect what seems as abnormal by using some crude techniques. So that is actually a dilemma, and actually the first decision, a very decisive decision that we are making when we look at the data.
Thanks, Kerem. And I think that's a key takeaway is we're approached oftentimes by clients that are very interested in pursuing AI, but at the end of the day, your data and the quality of the data and the availability of the data is going to dictate how useful it is. I think we won't go into too much detail on each of these examples, but they do represent things that we're doing and what we're seeing clients do within the scope of AI. But I think the other bit is the emergence in mid-sized institutions of this notion of a sandbox, for champion challenger activity and kind of offline analytics to make your operational analytics better. So we're looking at the poll results, and I think that's interesting. 12% are currently using AI in production. About 39.2% are either currently piloting an AI project, or they have plans in the very near term within the next 3 to 6 months. And then about the other, nearly 49% of the respondents currently have no plans to adopt that. So it's interesting, 50-50 more or less split. But just because you don't have plans doesn't mean that you might not be doing it sometime in the near future. So thank you for that. So we'll segue over into the industry examples, and I think that will illustrate to you that there are varying degrees of sophistication as we think about the use cases. The area where we've seen a tremendous amount of activity is within the BSA AML compliance area, really AML compliance globally, not just in the United States. And a lot of that is driven because there are so many manual processes, and the escalating cost of compliance really have not let up. AI is a really good use case for automating some of those processes. So we'll go through some examples. Hopefully, time permitting, we'll get through all of the examples we have today around auto referral or hibernation, process automation, automated rule generation, natural language generation, something that we're calling the surveillance bot that we've been working on here for the last several months, and some of the work that's being done around image recognition. So Carl, why don't you take us through an overview of what we mean by hibernation?
Yep, thank you, David. Yes, as David said, we're seeing a lot of firms kind of take different tactics to use artificial intelligence, and I think one of the ones that we're working with a lot of firms on is around reducing false positives in their AML or their AML or compliance groups, and really focusing in on the risks. So it's not just reducing the false positives, but then re-evaluating or basically focusing in on the actual risks that are most important to that particular firm. And one of the ways that they're doing that is really through what we call a hibernation model or hibernation function. And what that really means is that you're taking your existing alert generation process and you're going out and you're continuing to enrich the information that surrounds that alert generation. So that enrichment can include adding in additional details around the customer and the account that's related to the activity that's coming out of your rules or model-esque processes, and then going out and using all those different attributes to help assess the risk of either that particular transaction, the series of transactions, the customer themselves, or the accounts that they're doing the activity on, and bring it all in together on top of which you're also enriching and bringing into this process all of the known things that you already have around the experience, if you will, that you have around the customer or the account. So that could be, you know, prior cases, prior SARs, prior CTRs. It could be the risk scoring rating processes that you might have. It could be external information like law enforcement inquiries or subpoenas or negative news or other data points, if you will, that have something to do with either the customer or the account that's related to the activity or even related to the beneficiaries of those accounts or even the beneficiaries of the transaction, so the people on the other side of the transaction. And it's bringing all those components in together, and it's basically applying a scoring model against all of that activity and all of those data points, and then consolidating all of that scoring up to an entity level and creating what we called an entity level score. So what's happening is that based on all of the risks that you've associated across through all your risk assessment processes and also through your transaction monitoring coverage model evaluation, you bring all that together, and then what this does is that at this entity level score, you kind of set the threshold of where you think the risk is in terms of what you need to put in front of a human being. So hibernation is very different than terms like suppression, and I know that's a word that's not necessarily a word that's like to be used, especially in the banking industry. So what the difference between the two is hibernation isn't suppressing anything. It's not getting rid of any activity. It's not removing anything out of the equation. What it's doing is saying, I need enough activity, or I need to have enough risk based on your risk tolerance and your risk-based approach. I need to have enough risk to put it in front of a human being for action to be taken. And it also allows for additional things to come in over time, because maybe this particular pattern isn't as risky, but when this occurs and something else, when you bring all three elements together, that poses a big risk to your institution. And so what you want to be able to do is this hibernation approach allows you to really gather all the risky activity together and then apply, and then put that stuff in front of your investigation or your analysts to do their full-blown investigation. The other piece of that is that you can also additionally add in rules where if for certain kinds of risks, you definitely want to escalate those risks immediately and put those in front of human beings faster than other kinds of risks that may not pose as much to your institution. So having a combined approach, so it's not just solely based on a score. It's also based on your risk tolerance, and that risk tolerance can change. You may decide later on, hey, these kinds of risks we want to bump up, so you just make an adjustment to your scoring model. It's dynamic in the sense that it rescores everything on a regular basis, and so it's constantly changing based on the risks that your institution has and also the risks that are being posed by the marketplace. Now, to do this effectively, you need two things. One, you need ongoing monitoring, and you need to evaluate what's going on and the effectiveness of that monitoring program. So you need to evaluate the outcomes of the investigation and make sure that are these really the things that are risky, and you need to apply below-the-line testing, which means you need to look at things that are below the line, help you determine what you need to making sure that you're not missing stuff that you should be spending time on. And if you apply this holistic round-robin process, if you will, I think you're going to see some really good results. And we've seen anywhere upwards to that 30% SAR conversion rate adjustments. And that sounds like a lot, and it is, but it's amazing that as everybody knows, there's a lot of false positives, but a lot of it's not just that. It's also refocusing your institution on things that do pose the most risk to your firm. So that's definitely kind of how the hibernation model process works and some of the results that we've seen from that particular process. Another place that we're seeing a lot is around automation, and the term robotics is used a lot. To me, in my opinion, this is really just talking or can be associated to investigation efficiencies. So, I know from years of experience in the banking industry and in the financial crimes world, investigators take a lot of time collecting data, just collecting information day to day to evaluate an alert or to work a case or a combination thereof. I've got some numbers up here, 60, 70%. I think that's probably maybe even a little bit conservative, but it takes a lot of time to collect everything that's needed. To me, robotics is really nothing more than adding that automation to the investigation process. And so instead of an investigator going out and spending time bringing data or looking up data in different systems or going to external systems to look up a customer or collect a third-party information, have the system, let technology do what it does best, which is go out and automate some of that and go out and pull that data automatically, run queries against databases, or have APIs or basically web calls, if you will, that go out to different third-party data providers and bring back the information, run a query, bring back the information, and expose it to the analyst so that when they come in the morning and they open up their first alert, everything is already presented in front of them. And some examples are listed here. That could be anywhere from system of record data, data from your KYC system, your account opening system, from your payment system or your wire transfer system. Could be images like statements and checks and all kinds of other image systems. Could be third-party data like LexisNexis WorldCheck, other third parties, Google Map checks, running network analytics, pulling transactional history. You know, if you want 18 months of transactional history and you don't necessarily want to load it all into your Transmon system or your case management system, you can just have calls go out and pull the data forward. And it adds a lot of efficiencies to some of those processes that just take a while. And then even bringing in prior case and SAR narratives and representing that in some form so that the analysts can kind of work through that. And we're seeing, again, this is another one where we're seeing quick wins from a time reduction, and that's just working the case. It's not necessarily reducing false positives, but it's just reducing the amount of time the investigators have to spend going out pulling information. So again, 20, 30%, something we're starting to see with some of our particular clients. This next slide is really just kind of a simple automation view, if you will. And so again, it's just bringing forth information that the analyst already spends time looking for. Or it may have to go to several systems to pull forward. So again, it's just bringing it into a usable format, making that information and really turning that information turning that data into information and making it easy for them to make as quick a decision as possible, as opposed to spending all their time going out and collecting information. So that's just an example of what some of that could produce for a particular firm. Kerem, I'm going to turn this slide over to you and let you talk a little bit about machine-generated rules.
Thanks, Carl. Yes, I'd like to give you another automation example that probably touches the very conventional part of the financial decision-making business. Literally, pretty much all decisions in finance are actually driven by rules. There may be now very valuable scores underneath feeding into those rules, but typically the verdict comes from a business rule or a rule set. And traditionally, a rule set is an accumulation of domain knowledge. It's an asset to the firm, and it's conceived in industry experience. And of course, businesses shape them according to their needs and what they observe on the field. And some channels are particularly suitable for governance by rules. And digital payments, for example, is a good example, where the activity is characterized by many categorical attributes pertaining to many different parties involved in transaction. And these categories, this is inherently categorical data, and each category is very decisive on, let's say, a fraud risk if fraud detection is our problem. And the fundamental tool for handling categorical data and implementing rules on them in machine learning is the decision tree. So it's a very fundamental building block of many of the cutting-edge methods today. It has evolved into and takes part in many ensemble methods which are really on the field, but its history goes back more than 3 decades, and there are many principled methods exist to build decision trees. When you look at a tree designed by generated by a machine, it's actually pretty transparent. It is composed without a human involvement, but we have all the tools and exploration tools to look into a tree designed by a machine, and it's pretty transparent because if you follow a branch on a tree, it's actually, you can see all the data elements that goes into that decision, and the operations performed on each of these nodes is pretty simple. It's a simple comparison in contrast to convolutions or multiplications that do not make sense at first sight, quantify at first sight. And it follows a very concrete design principle. It is maximizing separation. So let's say a branch of the typical branch of 7-8 nodes that points to a fraud-rich bucket in a data is a pretty easy discovery for a machine, but it's a very hard discovery for a human being. But when you present such a branch to a human, it is pretty understandable by that human. And we owe this clarity to the highly structured and relational characteristic of the transactional data. And I want to make a contrast to other very active machine learning techniques which primarily work on unstructured and non-relational data, for example, the deep neural networks. Their features are also highly optimized and do tremendous things, but they are typically cluttered and hard to comprehend for a human reader. So this is something we gain by using trees on financial transactional data, that they can actually teach us if we follow what they have discovered. Back to you, Dave.
Thank you, Kerem. Another form of artificial intelligence that we're seeing in the industry is around natural language generation, and it's something that we're working on with several clients of ours. It's really, I mean, in simplest form, it's really just turning data and that's either coming in internally or externally or from third-party systems or third-party processes, and it's really just turning it into plain language. And the place that we're seeing this mostly applied is in generating narratives, whether those are case narratives, alert narratives, SAR narratives, STR narratives, and really at the end of the day, what this is another efficiency gain. So if I can turn things into easy, plain English, and I can take all the different elements like I was talking about earlier, activity and everything, and bring it into easy to read formatting, it makes it very simple for an analyst to read it, understand it, and then maybe even transfer that into some of the regulatory reporting or other kinds of reporting that they might have to do, even if it's board reporting or other kinds of reporting that they have in their organization. So natural language generation, I think, is another easy to, in my mind, easy to use artificial intelligence that firms are definitely need to be looking at, because it's a quick gain. It's another efficiency gain that can quickly add to your gain. Next one is the surveillance bot. So very simply, folks, this is really just a concept of the bot is really just artificial intelligence is meeting machine learning. And basically what this is what's happening here is you're able to capture data, and the data could be anything. It could be just the clicks that you're taking on your workflow. It could be movement of data from point A to point B. It could be service calls to go out and get data from third-party points. It could be data that's manually being entered into the system. It could be data that's being extracted into the system by way of ETL or other components. And it's using all of that information to help predict future steps for the human process. So for instance, if I'm going through and I for certain kinds of alerts, I always go to this screen, I go to another screen, and then I always do a web search, or I always do a negative news search. Instead of having the system have to sit there and every time the human being has to go in and do each one of those, the system knows for certain kinds of alerts or certain kinds of types of alerts, I'm going to automatically do that because the human does that over and over and over again. And this is actually saying, hey, this is the same thing, this is the exact same or similar thing that you did before, I'll just do it for you instead. And so it's actually machine learning from human interactions to either automate the process or to produce similar activities that were there. Or we're also looking at some things around recommending what that route should be. So what's the next step that they should take? So it's almost like task orienting the analyst or the investigator, giving them the tasks that they need to take because of what has been done in the past. So that's just another form of artificial intelligence that we're working on here at SAS. Kerem, I'm going to pass it over to you.
It's actually, yeah, I'll take this. Thanks, Carl. One area where, particularly within AML compliance, that has a tremendous amount of manual processes and is within global trade finance. And so there's some work that we've been doing with EY for the last 12 to 18 months in working with some of the world's largest financial institutions involved in global trade finance. And we've been using actually cognitive algorithms to do image recognition and entity extraction. And so by this, what I mean is, if you think of the example within international letters of credit, typically within a global trade unit, you'll have packets of information, and there might be 20, 30 different types of documents contained within each trade packet. And so we've applied AI or algorithms, if you will, to automate the process of recognizing the different formats of documents within these packets. So we can use classification analysis to decide, is that page a bill of lading? Is it an invoice? If it's an invoice, for example, based upon that classification, maybe then I can start looking for over-invoicing or under-invoicing, or terms that may be consistent with dual-use goods, things of that nature. And what's interesting, in some pilots with some top 10 global banks, we've seen that with about an 85% accuracy rate, we can automate those processes, which have, heretofore would have been manual. Another example that illustrates kind of the impact of automation when applying AI to some manual problems. When we think of things like Palestinian boycott language, in another pilot we scanned about 9,000 SWIFT messages, and for a human to review those messages would require somewhere between 5 and 7 minutes per message. And during this pilot, what we found is we could do the image recognition as well as the contextual analysis of those messages in less than a second per message. And so what we found in the pilot is we identified about 2.5% of those 9,000 messages really required some type of further action, and 2 of those messages were actually reportable based on sanctions laws. Now, when you start to step back and go, okay, what would be the business case for this? On average, it would take 2 man weeks or more to have analyzed that amount of the number of packets that we analyzed in that pilot. We were able to analyze those packets in less than a minute. So for that institution, an institution of that size and with that staffing, it was an 8-figure takeout for them within a given year. So the results or the possibilities are particularly intriguing when you look at the global trade finance problem. If you'll take us to our second polling question, Mike.
Absolutely, absolutely. As promised, here we go. So same drill as before. I'm just going to read through the question and the different possible answers here and give everyone a chance to answer. So where are you planning to adopt AI in the life cycle of detection and investigation? Is it in detecting illicit activity and fraud? Is it alert scoring, triage, or hibernation? Is it automation or information retrieval during investigations? Or is this not applicable in your case? So give just everyone a moment or two to consider that their answer to that question. And as before, what we're going to do is we're going to turn things back over and have a little discussion before we actually present those results. So those will be coming your way in a few moments. There you go. Take it away.
Thanks, Mike. Well, segue, we've talked a lot about automation examples, particularly those areas where there's substantial reputation risk, or in the case of fraud, where you have these rare events or behaviors that are occurring so quickly due to the sophistication of fraud, we're seeing those driving a lot of the application of AI into detection. So I'll take you through some examples: rare event fraud detection, digital payments fraud, natural language processing, and unsupervised learning. Can we look at the poll results? Okay, interesting. So almost 40% of respondents would apply AI more in the detection area, about 10% on automating of alert scoring, and about 20% in what we would think of as classic RPA or robotic process automation. And again, given that about half of our audience prior said that they were not, didn't have plans to execute, there's still a substantial amount that have no plans. So, Kerem, do you want to take us through what's driving some of the application of AI in fraud detection?
Sure, thanks, Dave. Detecting rare events in real time require thoroughly tracking the entire history of multiple entities involved in the transaction. So a high quality score can only be generated by observing and keeping track of who is involved in the transaction, and not only their individual history, but also their relationship. So the pairs between, let's say, two banks or two individuals really deserve a thorough evaluation in real-time scoring. So, and because new entities and relationships arise and they change their nature, they evolve in time, in production, one cannot really foresee and hard code all of these relationships and the possible behaviors in development time. So however representative the historical data is, we really need to teach a model, a rare event detection system, to be able to evaluate a profile, a time series, an entire history of these entities and their relationships. So our approach in tracking real-time behavior is very elaborate. We actually we insist on storing everything as time series, as raw time series. All the activity, be it amounts, be it country codes, or many attributes of the transaction at every entity, we track them, we preserve them, store them as time series, and make them available for real-time decisioning in very short amount of time, in milliseconds, and convert them into predictors on the fly. So there is still a fair amount of processing on these time series, but the information is stored as time series. There is obviously so much effort is being put in on this, making this available in this raw format. But like I said, the summaries are then calculated from these time series and compared against the current event for detection to calculate the risk, be it in the fraud detection case, the fraud risk. Can you go to the next slide, Dave? So one recent application of this approach is a digital payment model that we have recently deployed. It's a pretty successful one. It detects half of the fraud. It alerts on half of the fraud at the expense of only 0.5% of all the portfolio. It's a pretty small false positive rate in the industry. And like I said, it actually tracks many things in the transaction: the sender account, the beneficiary account, the online user, because the account can be attached to an online user or not, and even the text details like text entries that I will talk about very soon. And like I said, it stores all of this information as time series and leverages in real time. Then we derive tens of thousands of variables on these time series and provide different summaries. And we also use hard-coded risk tables as well. Like there are certain countries, there are certain static behavior that seem risky to the model. And on the top of them, we actually build an inference engine and try many different machine learning techniques, including neural networks, random forests, and gradient-boosted decision trees, and attain a champion out of these. And we do this in multiple iterations. We typically follow 3 full development cycles following all the development steps from scratch, and actually the resulting model is typically a champion over hundreds of candidates. If you go to next slide, Dave, and aside from the obvious attributes like amounts and geolocation, there are actually other details that we have a chance to look into due to this highly automation opportunity that we are having in modeling. So one of the examples that I want to talk about is these simple short text notes that the sender enters into a wire. And these are typically, they don't have to be very descriptive, all of them, but since they are entered by the sender, they do convey some characteristics of the sender. So one of the main applications of this that we were able to leverage in the model was a disambiguation of receivers being a business versus individual. That's a very important decision to make in terms of risk. And since the beneficiary is not an account, typically doesn't have to be an account that resides in our client, we might not know if it's a business or individual, if it's a third-party bank. And there are common synonyms, common pieces of text that one can immediately look to detect if it's an individual or a business. Or we can also attribute some characteristic n-grams that are specific to private names in English. And we also look at the history of, since we have the capability of store everything in the history in real time, we actually can compare them against the previous entries put in by the same sender. So here is an example of that. We can compare the text of a same institution that this person is making, and we can compare them with their synonyms or open forms and many different forms that they may take. We cover a variety of possibilities and then come up with a consolidated view that this person it's not abnormal for this person to send to an institution. And then we shape our score accordingly. So in short, no details actually should be overlooked in this kind of a very rich data source that involves many different parties and many different attributes. Back to you, Dave.
Thank you, Kerem. The last example that we'll give is what I just generally call an anomaly detection pilot. We were challenged by a very large global financial institution to mine some data and find things something that they didn't know about. It was a little vague when we first engaged with them. And really what they wanted to understand was more from a financial crimes compliance standpoint. Were there high-risk customers existing within their customer base that weren't properly classified? And so one of the challenges with this project is that we were given nearly 2 billion transactions, but we weren't given any labels. So if you go back to how Kerem described unsupervised learning, you don't necessarily know if people are good or bad. You're just looking for what we think of as edge cases or people that are behaving out of norm relative to their peers. So we applied some of our newer algorithms, a random forest model with 200 trees, and split out what we deemed to be potential customers who were behaving as money service businesses, but whom were not declared during the onboarding process as money service businesses, nor were they legally registered as money services businesses. So in a population of about nearly 2 billion transactions, we found what we thought were 416 suspected money service businesses, 89 previously unknown or unregistered MSBs, and which resulted through the further triage, resulted in dozens of productive cases. So it just gives you some idea of when you are going into an amount of data, being able to find things that are out of norm and might create some type of reputation risk for the institution. So I think we'll skip, Mike, the last polling question in the interest of time and bring us kind of into the home stretch of our takeaways and then save a few minutes for some questions. So Kerem, the first one takeaway was something that you're very passionate about. Tell us about that.
Yes, thanks, Dave. So our actually opinion is that machines should still not be entirely autonomous in decisioning, and especially so in finance. They need some sort of policing, and well, still certain and increasingly sophisticated tasks are being left to machines, which is great. But human intelligence in the process is still indispensable, although at an increasingly higher level. Examples of these involvements are to decide on when to update models, to collect and incorporate domain knowledge in retraining of the model. At least this can be even incorporating hallway conversations or certain inputs from unexpected inputs and evaluating them and actually making machines to address them. Not all feedback is coming through the data in retrain. So this kind of increased expertise in the domain needs to be translated for the machine, and we can't see a way other than humans to do that. And of course, to issue and enforce regulations is still a human job as we see it.
Thank you. The next one here is talking about artificial intelligence, and just really at the end of the day, although I think it can be so many different things. I think some folks get hung up on the term that it's complex, that it's stuff that it's net new, and it's stuff that I can't necessarily do here. I don't even know how to do artificial intelligence. My guess is that you've already are doing it and have been doing it. So again, in simplest form, AI is a mechanism to help automate leveraging technology and new technologies. So don't be afraid of it. Kind of embrace it. Figure out ways you can leverage it. We've just went through a whole bunch of use cases. I'm sure that most firms are doing at least one or two of those. And based on the polls, it sounds like this particular group is pretty proactive in leveraging artificial intelligence. I think the next one here is also just really at the end of the day, I don't necessarily ever see artificial intelligence as being a cost reduction or a cost efficiency perspective element. I do think it's re-leveraging or reallocating resources that today that they're spending time doing things that can be automated by technology, and then on the flip side, leveraging that resource to look for new risks or evaluate maybe additional risks that you just haven't had the time to look at in your particular firm. I don't see it as a cost reduction. I just see it as a cost reallocation process. And how can artificial intelligence help with that? Kerem, do you want to hit the next one?
Sure. Another point that I'd like to make is the technology, actually how cool it can be, however cool it can get, should not actually overshadow accountability. Decisions must always be transparent and explainable to reviewers, and this should guide both the development of an intelligent system, of an AI or machine learning agent, and the production life of such a system. And even if it costs money, even if it compromises efficiency somewhat, we think that the accountability is a key that's actually a long-term benefit to the overall field.
Thanks, Kerem. And the final takeaway should be obvious to everyone, but there's, we get asked at the water cooler, hey, are we doing AI? Someone else is, why aren't we? So we should do AI. We get a lot of inquiries that I feel may have come from that kind of train of conversation, but it's not about pursuing AI for the sake of pursuing AI. Hopefully you've heard today there are a lot of tangible examples where we can help automate processes and help you be more efficient, or perhaps detect behaviors that other traditional approaches are not necessarily effective at detecting, and really start with the business objective in mind. So if we want to wrap up with some questions, I know we have quite a number of questions queued up, and maybe we have time to take a couple of questions.
Yeah, thanks a lot, David. We do. We've got it's close to the top of the hour, but let's try to squeeze in maybe 2 questions here. So let me kick it off with this one. So can you automate client or regulatory reporting process using natural language generation?
So yeah, I'll take this one. So the bottom line is I feel like you can definitely automate the generation of the narrative itself in terms of being able to produce the actual language that you want to put together. However, I will just caution folks about completely releasing that language out into a regulatory filing that on behalf of your institution without some eyes and ears on it and evaluating what it's producing. I think natural language generation has come a long way over the last decade. I think it's a lot better than it used to be. I think it produces some really good results, and the things we're seeing is really good. However, I still think you need, at the very least, do some sampling and do some quality review of those narratives before you release it through onto the as what I would say as record to the regulator as on behalf of your particular institution. Once you get comfortable and you find that it is being able to produce it on a regular basis and it looks and feels good, then go ahead if you need to. So, but I still think you need at least some quality assurance process, maybe even post-processing, but post-processing is a little too late. But I would definitely do something on top of just creating it through technology.
Excellent, excellent. Thank you. Okay, here, let's see. Right at the top of the hour, but let's just get this one more question. We've got a lot of questions, and we're not going to get to everybody, but would love to get this last question in. Can financial institutions uncover false negatives with AI? I'll just toss it out to the assembled group, and anyone jump in that would like to.
I can do that. This is Kerem. So yes, as a kind of a side benefit, that might be possible as the accuracy and specificity of these detection systems, for example, improve. It actually enables a deeper and broader case analysis. So when working on a very specific alert on a very specific amount provided by an accurate detection system, actually the case analyst should dedicate a more thorough analysis investigating the neighboring accounts or any accounts that were in relation to this account, which otherwise would not be worthwhile on a more shallow or less accurate system. In that regard, analysts would be increasing detecting cases that were actually remained under the radar on the first pass of the analysis.
Excellent. Thank you, Kerem. And that does, we're about 1 minute past the top of the hour. We always really try to bring these things on schedule, respecting everyone's busy days. But I want to thank David, Carl, and Kerem for a great hour of discussion. And we got some really good questions here at the end, which is always a really nice sign that we're talking about something that people care about, which makes us feel good. Thank you, everyone, for being here and for asking these questions, for participating in those polls. As I thought, we might run out of time and wouldn't get to everyone's questions, and indeed that's the case. There are some questions here that we weren't able to get to in our time together today. But as I said, we will be following up afterwards. So thank you so much for asking those questions. You'll be hearing from us soon. Also, please keep an eye out. We're going to be sending you an email the next day or two that will have a link to the recording of this event as well as to the slides themselves, so you can review at your leisure in the future. We encourage you to do that. And with that, I will wrap it up. Wish everyone a wonderful rest of the day, and I hope you'll join us again here very soon. Thanks so much.